Welcome all of you to another video of Maths Made Easy. Now in this video we are going to do inequalities. Okay, inequalities of triangles. Sometimes this chapter seems to be little difficult for you all. So I want to take up this chapter and actually tell you where you go wrong. Please see the entire video. If you see the full video, you will start feeling that this is one of the easiest chapters which don't actually need any preparation the day before the exam. Okay, so let me start with it. So what is the concept behind this? First, the concept. Towards the end of the video, when you watch the full video, towards the end of the video we have a different concept. In the beginning of the video we work on one concept, and the second part of the video we work in a different concept. So let's see. Now inequalities of triangles, it simply says if I have a triangle A, B and C, if this angle is X and here this angle is Y, if angle X is greater than angle Y, then AC is greater than AB, means AC is opposite X, so that is greater than AB. Okay, so AC is greater than AB. That is what it tries to say. So greatest angle opposite the greatest side. So if this is 10, this has to be 7. Okay, greatest angle opposite, so this is X is greatest. Okay, and if I have a Z, which is the smallest angle here, smallest, then this has to be 5. Okay, so I'm just giving a small example. Greatest angle has the greatest side opposite it, smallest angle has the smallest side opposite it, always. Okay, and this applies for, this is one very important thing, this applies for one triangle. This rule will not apply if I have another triangle here, then it will not apply for combined for this triangle and this triangle. Okay, so let me see a few examples, then you will know it better. So here, see, we have a sum here which is prove that AB is greater than CD. Okay, prove that AB is greater than CD. What they have given us is only this much. AB is equal to AC. They have told us this angle is 60 degree, this angle is 40 degree. Now we have to prove AB, this is greater than this. Now note one thing, CD is in a different triangle, this is in a different triangle. Okay, so how do we manage that? Now that's what I'm saying, we should not take 40 from here and talk about angles in this triangle and apply it to sides of this. Nothing like that. Okay, so here if this is, how much is this angle? This is also 70 because angle ACB is equal to 70 degree because AB is equal to AC, right? And now how much is angle ACD? That is 110 because straight line, right? So it is a straight line, so this is 110. Now how much is CAD? Angle CAD, that is equal to 180 minus 110 plus 40, which is equal to 180 minus 150, which is equal to 30 degrees. So this is 30. Okay. In triangle ACD, this triangle. Okay. Then AC is definitely greater. AC is definitely greater because of this has 40 degree against it. Then this is the greatest side. This is the second greatest side because of 40. So AC is greater than CD. Okay. In triangle ABC, come to this triangle, then they have told us AB, means we need to involve this. Okay. And they have told us CD. So in triangle ABC, AB is equal to AC they have given. So in place of this AC, can I not write AB? Then only I get what they want us to prove. Okay, AB is greater than CD. Okay, so proved. So how did we manage this? Because AC was the common side between the two angles. So we could talk about this triangle and apply and use in place of this we could just talk about this, okay, because they are equal. So in place of this we replaced this, okay. So we didn't talk about this angle and this side, remember, okay. So we talked about this angle, this side, this angle, this side, but in place of this we just changed it to this, okay. So that way we can prove AB is greater than CD. Write BC, AC, CD in ascending order. BC, AC, CD in ascending order. Okay, now this is what they have given to us. Angle ABC, this is also 67, right? Angle ABC is a 67 degree. Why? Because AB is equal to AC. So isosceles triangle. Okay, base angles are equal. Now, angle BAC is equal to 180 minus 134. What is 134? 67 plus 67. Okay, that is a 46. That is a 46 degrees. Okay. So this angle is a 46 degree. Now they want BC, AC, CD. Let us locate the sides. CD, BC, AC. These three are there in the picture. Two are there in the triangle itself, but one is outside the triangle. Okay. AC is greater than AC and BC is there. So BC is smaller, AC is greater. AC greater than BC. Why is it so? Because this angle is smaller, this angle is bigger. So opposite to that, okay. So 67 opposite to that AC. So AC is bigger, BC is smaller. Okay. Now how much is angle CAD? Let us now start with this part of the triangle. In triangle ACD, angle CAD is equal to how much? Angle CAD is equal to, this is 67, okay. Exterior angle is sum of interior opposites. So this plus this is 67. So 67 minus 33, which is 34 degrees. So 67 minus 33, which is equal to 34. That means angle CAD, this is 34 degrees. Okay. AC is less than CD. AC is less than AC. This side AC is less than CD because here we have 34, opposite to that this will be bigger. Okay, so we got a relation between AC and CD. We need AC, CD, BC in the picture. Okay, so now we can say we have AC less than CD, we have AC greater than BC. So this is greater than BC. So can we write, we want in ascending order, smallest first, BC smallest, then AC, CD biggest. So we could write it like this. So note one thing, I have clearly calculated these statements based on the individual triangles. When I said AC and CD, they were sides of this triangle. When I said this AC, BC, they were sides of this. The only thing is we have to note which is the common side and use it for our working. Okay, so we have to make use of the common side in these sums. Okay, in triangle ABD, okay, let me first see where is AB and where is BD. AB is here, BD is here. Now note one thing, we have to prove this in this triangle. The only thing they have given is this is 90 degree. Okay, so the only thing that is given is this angle is 90 degrees. So this is also 90. Now in triangle ABD, AB definitely hypotenuse is always the biggest side of the triangle. AB greater than BD. Okay, so AB is greater than BD by the property greatest angle, because there cannot be one more angle which will be more than 90 or even equal to 90. So hypotenuse is always equal to the greatest side. So AB greater than BD. Any other side of the triangle is smaller than the hypotenuse in a right angle triangle. Now let's come to AC and CD. This is AC, CD. For the same reason, in triangle ADC, note one thing, I am remaining in the same triangle and talking about its sides. AC, this is AC greater than AC, again hypotenuse greater than CD. Okay. So I have got two equations from the two triangles based on the rule. Now AB plus AC greater than BC or not. So I'll just take these two equations AB plus AC and add them left hand side with left hand side, greater than BD plus CD. What is BD plus CD? BD plus CD is equal to BC. So this is BC and AB plus AC. Okay. So this is my AB plus AC grade. This is what they wanted. We got it by adding the equations. If you are not understanding how to add this, see, if I say 9 is greater than 13 and 4 is greater than, let's say, 12, then 9 plus 4, 13 is greater than 25. This is exactly what I did. Okay, here. Okay. Now we are going to do another new concept, you can say, which you have done in 8th standard also, which is sum of any two sides of a triangle is greater than the third side. Okay, sum of any two sides is greater than the third side. If I have A, B, C, then here sum of AB plus BC, AB plus BC will be greater than AC. Not just that, AC plus BC will be greater than AB. Not just that, AB plus AC will be greater than BC. Okay, now this is never going to be greater than equal to also. Actually, if you have done triangle constructions, you must have noticed, or you will notice later on sometime, that if they have given you such numbers which does not follow this, okay, then actually you can't draw a triangle. You'll have two sides like this and the third side does not meet. It remains like this if this is not followed by the values of the sum. Okay, the values of the sum must follow this. Okay, so this is it. So this is the rule based on which we are going to do further questions. This rule, based on this rule. Remember, this is not greater than and equal to. Even equal to is not allowed. And in order to get a triangle, or in order to form a triangle, all three have to be satisfied. Not that any one is satisfied. We have to get all three satisfied, only then triangle can be drawn with those sides. Okay. So here let me take up one question. In a quadrilateral, okay, in a quadrilateral ABCD, AB plus BC plus CD is greater than DA. AB plus BC plus CD plus DA is greater than twice AC. AB plus BC plus CD plus DA is greater than twice BC. Okay, so we have to prove this, prove that. Okay, now here is the quadrilateral. Quadrilateral, remember, it is a random quadrilateral. We are not going to make it any of the special quadrilaterals, just a random quadrilateral. And then we are going to join them because we have AC here. Okay, so that's why we should join them. Now let's take the first one. How to prove? AB plus BD, AB plus BD is, I'm applying the same thing. In which triangle? In DAB triangle is greater than AD. Okay, BC plus CD greater than BD. BC plus CD is greater than BD. Okay, two statements for two different triangles. Now I am here, AB, BC, CD, DA. Okay, so let me look here. AB, BC, CD. Okay, I'll add AB like in the previous question. BD plus BC plus CD greater than AD plus BD. Okay. AD plus BD. BD and BD cancels. AB plus BC plus CD is greater than AD. So we are done with this. Let's try out this. AB plus BC plus CD plus DA. AB, BC, CD, DA. Okay, and we have twice AC over here. Since we have twice AC, we are going to consider the triangle ABC and ADC, because in that case we get AC two times. Okay, so in triangle ABC and triangle ADC, AB plus BC is greater than AC, AD plus DC is greater than AC. Okay, add them. AB plus BC plus AD plus DC is greater than twice AC is greater, so we get this. Look at it, nothing cancels here. Okay, now we have the third one which says twice BC. Okay, 2 times BC here. How to do that? Okay, now here we have the third one which says twice BD. Okay, twice BD. So let me see which triangles we can take. Okay, so we will take BD, DA plus BA is greater than BD, and DC plus BC is greater than DB. Okay, BD and DB is the same thing. Now I'll just check here. AB is there, BC is there, DA is there, DC is there. Yeah, so if I just add the left hand side, BA is AB plus DA plus DC plus BC is greater than, this is also BD, this is also BD, twice BD. Okay, so we changed the triangles. So I took this triangle and this in order to get BD twice. Okay, ABC is an equilateral triangle. P is any point. P is any point. Okay, P is any point. Prove that P is any point on AC. On AC. Prove that. What do we have to prove? Okay, BP is greater than PA and BP is greater than PC also. We have PA here and PC. BP is greater than this and greater than this. First thing, if it's an equilateral triangle, without even thinking about the question, mark these as 60 degrees. This full thing was 60. So this part is less than 60. This part is also less than 60. That much we know. Okay, now we have to involve BP and AP in the question. So let in triangle APB, let me think about BP and AP. AP is less, opposite AP is less than 60 and opposite BP is 60. So BP is greater than AP. In triangle BPC, opposite BP is 60, opposite PC is less than 60. Very simple. So again BP is greater than PC. Okay, so I got both of them in separate triangles just by knowing that these were less than 60. The parts were less than 60. Okay, parts are always less than the whole. So I got it. XYZ in ascending order. Okay, XYZ in ascending order. Write XYZ in ascending order. This is the triangle. These are all exterior angles. See? Okay, now AB is the largest side and BC is the smallest. Okay, BC is the smallest. Where is BC? BC is smallest, AB largest. What to do? If AB is the largest side, that means angle ACB is greater than, BC is the smallest, then angle is the greatest angle. This is the greatest angle if this is the greatest side, is greater than angle BC, and the smallest one of course is opposite BC, which is angle BAC. BAC. Okay. So ACB, ABC, BAC. This is the smallest. Now here angle ACB, angle ACB. So Z is equal to 180 minus angle ACB. Y is equal to 180 minus angle, Y is here, angle ABC, and X is equal to 180 minus BAC. Now out of XYZ, this number is steady. This is the biggest, so Z becomes the smallest. Then this is the one in the middle, ABC, which is between these two angles. Therefore, this is also in between. And X was the BAC was the smallest angle. Therefore, when you subtract it from a constant value, X is the largest. So, this is what you have to write. So, we have written it in ascending order also. Now, here is a question. You have a triangle here, and they told ED is equal to EC. ED, EC are equal. Prove that AB plus AD, where is AB? AB is greater than BC. Now this, okay, not even this. Had it been this, it would have been a direct question. Greater than this. How to prove this? AB plus AD greater than BD. That comes straight from the rule. Okay. Sum of two sides greater than the third side. Then CE plus EP. CE plus EP. Okay, CE in this triangle, CE plus EP is greater than CB. Now we have somehow brought CB in the picture in a different equation. Now here we'll add them. AB plus AD plus CE plus EB is greater than BD plus CB. Okay, is greater than BD plus CB. Then we have AB, AD, CE, EB. Now here we have to make some changes. BD is ED plus EB. ED plus EB plus BC. Okay, CB and BC same. AB plus AD plus CE plus EB. Okay, now look here. CE and this is EB. I have EB here, I have EB here. So it gets cancelled. Okay. Then CE and CE is equal to ED. So if I have CE here and I have ED here, they are equal. So that also gets cancelled. AB plus AD is greater than BC. Okay. So after adding and cancellation, we get what they had wanted. They had wanted this, we get it. Okay. So these were few of the questions I felt were little different types. Rest are same types. So you can do the exercise now after seeing this video. Okay, so that's it for today. If you have liked the video, please subscribe. Please leave a comment. I tell it in all my videos. Please check the playlist also for more videos. Lots of more videos in simultaneous equations I have in it has taken up age separately, distance separately. All types of simultaneous equations I have separate videos, so please check them. Okay, so that's it for today. Bye then.